Okay, so this week you're actually going to work on the lesson that deals with the trinomial factoring. I had you do some trinomial factoring last week. You had a worksheet that you had to do. I'm just going to review that information with you. And then I do want to talk about overlapping right triangles. So the first thing in trinomial factoring, remember we want to put it in descending x exponents. So we're going to start with our squared term. And the next exponent is going to be to the first power, so we would put the term negative 5x plus 6. All right, if you remember from last week, we talked about taking this trinomial, which is a quadratic because the highest exponent is 2, and the first value in each set of parentheses is going to be x, just because the first term has a coefficient of 1. And the first values we put in each binomial or each set of parentheses has to multiply together to give you that value of x squared. Now the next thing that we look at is we look at this sign right here. It's a positive 6. So I want to come up with the two numbers that I need to put in these sets of parentheses that when multiplied together give you positive 6. So the last two values when multiplied together in the foiling process should give you positive 6. To get a positive, the signs are going to have to be the same, because a positive times a positive is a positive, or a negative times a negative is a negative. Since this sign right here, the coefficient of x, happens to be negative, that tells you here the first thing is that the signs are the same, and the second one tells you that they're both going to be negative. So I'm going to go ahead and put my signs down. Now when multiplied together they give you 6, so those factors are 1 and 6 or 2 and 3. And you need to think about which ones do I put in, so when I multiply outer and inner together I get negative 5x. Now if you were to try 1 and 6, you're going to notice that the outer multiplied together is negative 6x and the inner gives you negative 1x. They're both negative. When you group them together, that gives you negative 7x, which is not what you want. So we want to get rid of that. It's easy just to think that you could change a sign, because 6, and if you had a negative 6 and a positive 1, that would give you the negative 5, but the signs have to be the same. So let's put in 2 and 3. And when you put that in, the outer is going to give you negative 3x. And the inner gives you negative 2x, and the outer and inner need to combine together to give you this 5x, which they do. So your factored form for this first example is the quantity x minus 2 times the quantity x minus 3. Now the next example, the x squared coefficient is not a negative. It is not a 1. Sorry, I was distracted by some people for a second. So that lead coefficient is not 1. It happens to be a negative 1. So the first thing we want to do is see if we can factor out any common factor. And since this is a 1 and it's negative, I'm going to change every single sign by factoring out negative 1. So if I factor out negative 1, that changes every single sign to my trinomial. So I get positive x squared minus 5x minus 14. Now from there, I want to go ahead and work with that trinomial and break it into the two binomials, or see if I can factor it. So x squared factors into x and x. The next thing I want to look at is not the sign up above in the original problem, but I want to look at this negative 14. So the two values that I'm going to put in this slot when multiplied together have to give you negative 14. Since it's a negative, that tells you that your signs are going to be different. So I'm going to put a plus and a minus. I don't care if you put the minus first. I just happen to always go positive, negative for the most part. Now the factors of 14 are 1 and 14 and 2 and 7. Now more than likely, Saxon will use the two that are closer together. So if we go ahead and put in 2 and 7, now I'm going to do this in pencil first. If we look at the outer and multiply those together, you get negative 2x, When you multiply the inner together, you get positive 7x. If you group those together, you are going to end up with positive 5x. You want negative 5x. So what you would do is you would have to change your signs. Now, just because I put mine in pin, I'm just going to switch the two numbers around. So you would have a positive 2 and a negative 7. When you multiply the outer together, you get negative 7x. And when you multiply the inner together, you get positive 2x. And if you group those together, you do get this negative 5x. Now keep in mind this, some things that you were doing wrong on your worksheet that you turned in is some people forgot to leave the negative 1. The factored form, you have negative 1 times the quantity x plus 2 times the quantity x minus 7. Now the other thing that I was going to say, don't forget this greatest common factor that you factor out. The other thing is to also make sure that when you are trying to come up with your signs and what the outer and the inner should equal in your factored form, you have to go to this step right here and not to the original problem. So this next example, once again, the first thing, make sure they are in descending x exponents and make sure you take the sign that is associated with that term. So it's negative 3x squared plus 6x and then plus 24. We have a greatest common factor that we can factor out of each one of these terms. You can factor a 3 out. So if I factor out a negative 3, I get x squared. Don't forget I'm factoring out a negative, so that changes the sign. So it's negative 2x and negative 8. So if I were to distribute that negative 3 back through, I would get back to this middle equation right here, which is negative 3x squared plus 6x plus 24. Now that I have it in that form, I can go ahead and keep that negative 3 there. Like I said, that's what some of you forgot to do on your worksheet. And I know that multiplied together now gives me this first value of the first values I want to put in parentheses. Gives you the first term of your trinomial. So that's going to be x and x. That gives you x squared. The next thing, this negative sign right here in front of the 8 or your constant tells you that you're going to have different signs. So I have a positive and a negative. And just for speeding this up a little bit, the factors of 8, you would have 1 and 8 or 2 and 4. And I noticed that in this format that I have it in, if I were to multiply the outer together, I get negative 4x. And if you multiply the inner together, you get positive 2x. And that does give you negative 2x, which is what we are looking for. So your factored form is negative 3 times the quantity x plus 2 times the quantity x minus 4. Okay, example 4, we want to put it in descending x exponents. So you're going to have negative 2x to the 4th plus 12x cubed plus 32x squared. We can factor out a common factor of 2 and x squared. So the greatest common factor is negative 2x squared. And when you factor that out, you're going to be left with x squared minus 6x. Remember, that sign's going to change because of the negative 2 that you pulled out. And then negative 16. And I factored out all of the x's. So we move on to the next step. And what we want to focus on is factoring out this trinomial right here. But keep in mind, you have to keep that negative 2x squared with your value. So as I look at it, the signs are going to be different. Looking at that negative 16 tells you that the signs will be different. So I have a negative, or a positive and a negative. The factors of 16 are 1 and 16, 2 and 8, or 4 and 4. So if I look at 8 and 2, just to save time, I don't want to do it wrong. So the outer is going to give you negative 8x and the inner gives you positive 2x. And if you group those together, you get the negative 6x for that middle term that we are looking for. So your factored form is negative 2x squared plus 2x minus 8. Okay, the last thing that I want to talk about is overlapping triangles. If you had just this diagram on the top, this large triangle that has another small right triangle inside of it, we can draw that as two separate triangles. So this first triangle is this one right here in red. And then the second triangle that I have drawn is the whole large rectangle, which we look at right here, where the base is 5 plus 3, which is 8. The height is c, and the hypotenuse is the sum of a plus b. Now the first thing I would do is I would use Pythagorean theorem to find a, or you could find c. I'm not going to find b the way they tell you in the book, but I will show you how we will do it. It's a way we've talked about already. So Pythagorean theorem, I know I'm going to have 5 squared plus 4 squared is equal to a squared. So you get 25 plus 16 is equal to a squared. If you add those together, you are going to get 41 is equal to a squared. So as a last step, you get rid of a square by taking the square root. So a is equal to the square root of 41. So I'm going to come back up here and redraw this triangle. And within that triangle, I will label just these base values of 5 and 3. And we found a to be the square root of 41. Now we've talked about before how if you have parallel lines, and I have these parallel lines here, cut by two transversals, which are the two blue transversals that you see, you get a proportion that's set up. And in that proportion, usually we look at it in this format right here, and we said to solve, you cross, multiply, and divide. So if you cross multiply, you're going to take 3 times radical 41 and divide by 5. So b, this is the way I choose to solve for b. b is going to be equal to 3 cross multiply and divide to find b. So you get 3 radical 41 divided by 5. I find that easier than trying to set up a proportion, because that proportion would look like a over 5 is equal to a plus b over 8, and you would cross multiply. I mean, this is doable, but you're going to have 8a is equal to 5a plus b. Go ahead and move the 5a over by subtracting it, so you get 3a is equal to, I didn't use the distributive property there, that should be 5b. Sorry, multiply those together. So then you get 5b, so you're going to divide by 5, and then we mentioned how a had a value of radical 41, so you get 3 radical 41 over 5. Now you could substitute in radical 41 when you began and left this as radical 41 plus b, but sometimes that gets confusing for people. And then the very last step is to find c. So in order to find c, I'm just going to set up my proportion right here. So I'm going to say that 4 over 5 is equal to c over 8. So if you cross multiply and divide, c is going to be equal to 8 times 4, which is 32, and divide by 5. So there's how you solve overlapping triangles. I hope this helps. Your assignment then is going to be lesson set 26, 1 through 30, and that will be due Friday at 11:59.